In this very short podcast, we're going to look at a couple relationships regarding segments in circles. All right, so here in class we looked at tangents, and this is in your notes already. If we have two tangents and they intersect in a point, then those two tangents have to be congruent, and we actually proved that to be true. Okay? So if you have two tangents, you know they're tangents, and they intersect, you can just set those tangent segments equal to one another and solve. They're going to be congruent. Right? So I think that's pretty straightforward. We're going to look at one more segment, actually two more segment relationships, but they're sort of related. If we have two segments, and by the way, this is not in your notes, but I attached the diagram and the writing, the most important parts, in your next set of notes. So you don't have to worry about writing this down, but do remember it, because you're going to see it in a question soon. So if we have two congruent chords, so in a circle or congruent circle, we have congruent chords. Congruent chords have congruent arcs. Right? So that means that if the chords are the same length, the arcs are going to be the same length. Right? And that makes sense, because if the chords are the same length, they're going to slice off the same amount of the circle. Right? So if AB is congruent to CD, then arc AB has to be congruent to arc CD. And that works the other way as well. So in a circle or congruent circles, congruent arcs have congruent chords. So if arc AB is congruent to arc CD, then segment AB has to be congruent to segment CD. It works both ways. And then one more relationship we'll look at. In a circle or congruent circles, in a circle, parallel chords, I'm reading the same thing again. In a circle, parallel chords intercept congruent arcs. So I think this should have been up a little bit higher. So this goes together with the top picture, and this goes with the bottom picture. So in a circle, parallel chords intercept congruent arcs. Note that the chords are not necessarily congruent, just the arcs are. And that makes sense. If the chords are the same distance apart from one another all the way through, right, they're going to slice off the exact same amount of the circle. So if AB is parallel to CD, then arc AC has to be congruent to arc BD. Right? All right, so let's look at a problem involving that. We've already solved tangent problems, but let's solve a parallel chord problem. All right, so AB is parallel to CD. There we go. If the distance around the circle from C to D is 180 degrees, okay, so that's 180 degrees. What is the measure of arc CA? What's that measure there? Right, so you might have wondered how I knew which way to go around the circle. Well, actually, it isn't going to make any difference. The other direction is also 180 degrees. All right, so let's see some things that we know. So we know that the whole thing together has to equal 180 degrees. So that means that arc CA plus arc AB plus arc BD has to add up to 180 degrees. We know arc AB, that's given to us, that's 80 degrees. All right, so, but what do we know about arc CA and arc BD? We don't have their measures. Well, one thing we do know that if the arcs are going to be, or if the lines are going to be parallel, the chords are parallel, these arcs have to be congruent to one another. So since AB is parallel to CD, then we know that arc AC has to be congruent to arc BD. All right, so that means that whatever they are, they're the exact same measure. Let's just call them X. All right, so that's going to be an X plus an X equals 180, and we can add those like terms together, right? So that would be 2x, x plus x is 2x. So 2x plus 80 degrees equals 180. And if we subtract 80 degrees from both sides, 2x is equal to 100, which means that, oops, I'm going to divide by x, not, I'm going to divide by 2, not by x. Just get rid of that. I was thinking what my next step was going to be after I divided by 2. And that next step was going to be x is equal to 50 degrees, which means that arc CA is equal to 50 degrees. All right, so we can use those relationships to find the measures of some arcs. And some tangents, right? Congruent tangents. So you'll see some questions involving some parallel chords, intersecting some arcs, and therefore they're going to be congruent, and some tangent problems. All right, so bye for now, and then we're going to pick up with central angles.